Okay, so I just want to give a really quick rundown on how to use some of the tools that we're going to be using in this lab. This lab is all built for Windows, so we won't be using the seed environment at all, or Linux or anything like that. So the first tool you're going to need is a tool called CFF Explorer, which stands for Common File Format Explorer, and we're going to be using it to explore the portable executable file type, and that is probably what you know just as the .exe files, Windows applications that you're used to running on your computer, if you have a Windows computer. So we've opened the file ratchet.exe in CFF Explorer, which you can just do by doing file open. You don't need to do safe mode, it doesn't really matter. And so here we can see that we have some interesting information about the file. We have the created date, which is actually the last time that the file was created or opened, so that was pretty recently. And that also explains why the created date can be later than the modified date. The modified date is the last date that the file was actually changed. And the accessed date was, again, the same as the created date in this case. And then down here we have a couple things like the MD5 and the SHA-1 hashes of the file. So we're going to need that information for this lab as well. So if we go in here into the left-hand side, there's some other interesting tabs we can look at. So for starters, this file header tab has a time date stamp field. So this is actually the compile time of the file. So this value right here is in hexadecimal. So in order to figure out what date and time this actually represents, we will need to convert this hexadecimal value to decimal, and then we will need to take that decimal value, and since it's stored as a Unix timestamp, that is the number of milliseconds since the Unix epoch, and Google can just help us convert that back into a normal date and time. So then another thing that's kind of interesting in here is if you look at the characteristics tab, there are a bunch of little boxes that are kind of checked that show you interesting things about the file. So in this case, we see the file as an executable, but not a DLL, and also that it was compiled for a 32-bit word machine. So a couple other things that might be interesting in here. The import directory is a pretty interesting one. So this shows us the libraries that are loaded by the executable. So we can see in this case that addvappy32 is loaded. So if you click on that, then you can see down here the actual functions that were called from that specific library. So inside addvappy32 DLL, there is a function called reggetValue, and we can look up on the internet what that function does if we're interested about that. Then there was another DLL that was loaded called WS2, which stands for WinSoc2. So this is the Windows networking library. And again, if you want to know any more information about any of these DLLs, you can just go to the internet and look up the APIs for those. So this WinSoc32 DLL actually imported a bunch of functions here, and unfortunately CFF only recognizes them by their ordinal value. So instead of having a function name here, it just has an ordinal. So there is probably a way that you could look this up, but this is just kind of an unfortunate side effect of the way that the file was rendered by CFF and the way that it was compiled. I've seen some machines that have actually just had the function names right here, so maybe you'll get lucky and have those. Maybe you won't. Maybe you'll just have the ordinal values. But either way, just know that WS232 is the Windows socket API. So this is going to deal with networking. So these functions are something to do with networking. We don't know quite what at this point. The last thing I want to look at here in CFF is this hex editor tab. So if you click on that, you can see this is actually a hex dump of the entire file. So these are all the bytes of the executable. And we can scroll down. You can see there's going to be a lot of bytes in here and a lot of data. Most of it's not really understandable or printable because, again, this is a binary file that is executing machine code. But still, if you do go down far enough, you will probably see a few things that are at least readable. Some of these might be of interest to you and some of them might not be, but again, there's just some data in here that you can look at. So next we're going to look at Procmon. Okay, so now we're going to use a tool called Process Monitor, or Procmon. So once you have that installed from the internet, you can go ahead and just open it. This user account control menu will pop up. Just go ahead and say yes. And now we hopefully have to set our filters. So we're going ahead and create a filter. Just ignore those. I had those set up from earlier. I'm going to go ahead and create a filter for process name. And we want that to be is. In our case, we're going to make it ratchet.exe because we want to just track the activity of this application. And then we're going to include, and we're going to add that. So you should see that this pops down here with check. Go ahead and hit apply. Okay. So now we've got this window right here. It's empty right now because ratchet.exe has not done anything yet. We want to go ahead and make sure that capture events is checked. And also that drop filtered events is checked. That will just make sure that we don't run out of memory in here. So once you got those set, you can go ahead and find your program ratchet.exe, and you can actually go ahead and run that. So I went ahead and did that, and it looks like a lot of this stuff populated in the process monitor. So these right here are all sorts of events that the process did, and I'm just going to go ahead and full screen this so we can see it a little bit better. You can see all kinds of information, registry, this reg open key function was called a lot, close file, create file. So there's a whole bunch of stuff that happened, and a lot of this is really not important. A lot of this we really don't need to worry about. However, there are a few things in here that are interesting, and I don't want to give away any of the answers, so I'm going to let you guys go ahead and try to figure that out. But there are some things in there that you will want to look at and try to figure out what the file is doing. So that is, in a nutshell, how to use Process Monitor. Once you're done, you can go ahead and uncheck Capture Events. And yeah, then hopefully you can figure out what's going on from that. Okay, so at this point, we have already looked at the file in CFF Explorer to get some initial information. We've also run it one time and looked at what kind of happened in Process Monitor. But we're not done yet, unfortunately. So we have to do a little bit more work to actually figure out what this file does. Once you've done the last section, you probably thought, wow, this file is kind of relatively benign. What's going on? But no, trust me, this file is actually malware. It is legit malware. So we're going to have to figure out what it does. And the way we're going to do that is we're going to use a tool called IDA, which stands for the Interactive Disassembler. So this is actually going to kind of take apart the file from the executable and kind of put it back into the assembly language. So the way that we do that is once you open up IDA, you can just go ahead and click New. You want to disassemble a new file. And then you can go ahead and find ratchet.exe where you ever have that. And pretty much all these defaults will be okay. You don't really have to change anything. If you want to check the load resources, you can, but you don't really have to. So you can just go ahead and click yes through that. And here we are. All right. So this has dropped us off in the file. So here we have a little bit of x86 assembly, and it jumps to this one spot. So once you get here, I'm actually just going to say that you can hit the G key to jump to an address, and just go ahead and type 411.920. So this is actually where the main method of the program starts. You could spend a lot of time trying to find this, but I figured it would just be easier if I just told you where it is. So in this case, we're just going to go to this this function right here, sub underscore 411.920. So that's where we are. So just to kind of explain a little bit of what's going on, because this interface can be kind of busy, these are all variable names that IDA uses, and these have these negative offsets. So those are variables that are local variables to this subroutine, and things that have positive offsets, so the things that like have an 8 or a 0C in front of it, are actually arguments to the program. So these are arguments and these are local variables because these have positive offsets and these have negative offsets. So there are two arguments, and since I told you that this is the main method, I'll also tell you that this is a C main method. So in the C main function, we usually have two arguments to the main method, and those are usually argc and argv. So in this case, that is actually what these represent. So I'm going to go ahead and hit the N key, which will allow me to rename this variable. And I'm going to change the stack variable name from arg0 to argc. And for those of you who might not have done C before, the C is stands for count. So this is referring to the number of arguments that the program entered in. And so the second one, instead of arg4, I'm going to hit the N key once again, and I'm going to rename that to argv. And argv represents kind of the array of arguments. So if we want to access different arguments, we're going to use offsets into the argv array. Okay. So these first few lines of assembly, I'm just going to kind of skip past. We don't really need to know. This is kind of function prologue, pushing variables onto the stack and things like that. And we see a couple other things like this repstosity and the move and these XORs. There's a lot of stuff going on. And one of the things that I'm going to try to get at is that we don't really need to understand all of this detail here. What we really want to do is try to figure out what the important stuff is that's going on in this code without understanding every single line of assembly. So that's going to be difficult to do, but one of the ways that we're going to do that is by kind of trying to look at the program flow, and that's one of the reasons that IDA is really nice, is that it builds this graph of jumps for us. So anytime you see these two arrows, you know, a red arrow going one direction and a green arrow going in another direction, that is actually referring to different paths that the program can take based on the value of these jump statements. So these jump statements in assembly basically tell us, you know, based on some condition, we are going to either, you know, go to this side or we're going to go to this side. And in order to figure out what the condition is, we can actually look up at these compares. So pretty much anytime you see a jump statement, any sort of conditional jump, so this J and Z stands for jump not zero, we're going to want to look up ahead to see what sort of comparison was done in order to make that jump. So in this case, what's actually happening, and again, since we've renamed this argc variable from before, we know that we're comparing the value of argc to the number 1. So we're checking if the number of arguments is 1. And if the number of arguments is 1, we are actually going to go in this direction. The reason that the number of arguments is 1 in C is because the name of the executable is actually the first argument. So let me kind of explain what I mean by that, because that can be a little confusing. So if you have a command prompt in C, and I wanted to execute some C code, say that I have a file in this directory called ratchet.exe, I would execute that by typing, you know, ratchet.exe. And this file name right here is actually considered the first argument. So in this case, if I just hit enter right here, C would consider that I had 1 argument. So in this case, argc would be 1. So that would be the case where we do go this direction. And that could be kind of confusing because you might say, hey, there are 0 arguments here, but there's actually, according to C, there is 1, and that is the name of the executable. So anyways, that would be a case in which you'd go that direction. And if you wanted to go in the other direction, you know, you could go down this green path and kind of figure out what's going on. So then you can see there's another compare here, and based on the result of that compare, we go, you know, either to this code or to some other code. And since this is the assignment, I don't really want to talk a whole lot more about, you know, what specifically is going on here. But a couple things that I will say about this are that do your best not to get bogged down in the specific lines of assembly and what they do. Kind of try to look at the strings, the human readable stuff that's put in there. That's there in order to kind of help you figure out what's going on. Nothing's trying to trick you. And then also look at the jumps and which directions things are going. Try to figure out, you know, the cases in which one program takes one path or the other. And then once you've made it to the end, you can kind of make your conjecture as to what's happening. Oh, one other thing that I will say also is you do not need to go into any of these calls down here. So you don't need to go into any of these other functions. You could do that by double clicking on it, but you don't want to do that. You will be able to figure out everything that you need to know about this file by staying inside this function. So do not go down into any of these calls. They will just mislead you and take up your time. So that's kind of a general introduction on how to use IDA. Once you've figured out information about using IDA, then hopefully you'll understand this file a little bit better. And once you understand the file a little bit better, you will know how to use the last part of the assignment, which is what we're going to show next. So I really quickly want to end by showing how to use Wireshark, which is a tool that is used to capture network traffic. So it can kind of help you see the networking requests that are going in and out of your computer. So when you double click on Wireshark and you open this page, it'll ask you which interface you want to capture on. In my case, I want to capture on Wi-Fi just because I am connected on Wi-Fi right now and not Ethernet. So I'm going to go ahead and double click Wi-Fi. So you can see there are a whole bunch of networking requests that are being transmitted kind of in the background right now. So I'm just going to go ahead and make a simple networking request. Normally, so when you're doing your assignment, this is the point where you will actually execute ratchet.exe, hopefully with some new information that you discovered from IDA. And by doing that, you will you'll hopefully be able to see some networking traffic coming from the executable. but since I do not want to give away the answers to the assignment, I'm actually just going to go ahead and make a generic network request. So I'm going to go www.mscs.mu.edu, and it's going to take me to marquette.edu/mscs, and we see all this, great information on this web page, beautiful web page. And so yeah, and now in Wireshark, I'm going to go, and I happen to know that the IP address of Marquette computers usually starts with 134.48. So I'm going to go ahead and filter in Wireshark. So if you right click on one of those lines, you can actually do apply as a filter selected. So now you see that Wireshark changes it so that we're only looking at all of the traffic where the destination IP address is 134.48.29.23. So these are all the individual packets that are going from us to them. And if we want to see the whole thing as an aggregate, we can right click again and actually go down to follow and do TCP stream. So this will show us the whole back and forth that was happened between our computer and Marquette when we went to mscs.mu.edu. So in this case, we see that the client packets are highlighted in red by Wireshark. It kind of has that down here. There's 3 client packets in red, and the server packets in this kind of bluish purple color. So since Marquette now uses HTTPS for everything, a lot of this data is encrypted, and as a result, we can't really see what's going on. We do still see a few, readable things like the word IT services and the marquette.edu domain. So we can get some stuff from that. When you do run your executable, the executable that we gave with the correct arguments, you will find that certain things happen, and those things are in clear text, so they're not encrypted like this traffic. So it should be pretty easy to understand what's going on from a networking standpoint when you run that file. So once you've done that, you'll kind of be able to figure out how the client and the server are communicating, and that will really help you get a feel for how the malware works.